Hello everyone, it's October the 6th. It's very late, 10:35 p.m. my time, and unfortunately, we gotta take a look at this. I forgot that the time zone for LeetCode has changed. So they're now using UTC, which is about, I think, 7 hours ahead of me, which means that the latest I can do for like today's daily challenge is 5 p.m. and I missed it. I was in school and then doing some stuff, and I completely missed it. That means if we want to fulfill this, I mean, there's still in my day. So what I need to do, I think, is I need to go redeem and pick up a time travel. So I think I'm gonna do a time travel ticket. So let's just say redeem. And all right, start using. I actually don't know. Am I using right now? Oh yeah, I have one. So I'm gonna go here. So this is actually today's, but because of the time zone issue, they already released tomorrow's, which is this is tomorrow's, right? So today is gonna be this. Find all duplicates. I don't think I've done this before. I just did it, and I just said I thought I didn't do this before. All right, so we've done it, and look at this. Short succession. All right, so shouldn't be too bad. Find all duplicates in an array. Given an integer array of length n where all the integers. Oh, wait. If it's August the 6th, then I have actually. I don't think I have a video for it, but I should have a my code. Yeah, I think I have the code. If you take a look, yeah, August. If we list, let's say 2020 August challenge. Oh no, I do not. I started recording. No, not start recording. I started saving the code on the 9th, so I don't have for the 6th. Ah, alrighty. Let's see. So nums of length n of all the integers nums are in the range 1 to n, and each integer appears once or twice. Return an array of all the integers that appears twice. It must run on on time and then use only constant extra space. I was going to say I must use counter, right? If you do counter and yeah, you do a counter and then you return the ones. I think counter has Python counter. Counter has a function, I think, that can return the topmost. Yeah, if I remember correctly, it has a topmost. I mean, I never use have I used order dict? Not really. Name tuple. Actually, I never used name tuple. I should. I've seen name tuple many times. What does it do? Name tuple subclass. A tuple-like objects have few accessible by attribute lookup, as well as be indexed and iterable. Subclass has helpful docstring. Oh, name tuple. Point xy. But what does that mean? Well, a field name, right? P was point essentially was positional or keyword argument. P0 plus P1. A point. That's the name. That's the tuple, right? Is that what it is? Type name, field names. Type name and field names. The field names are a sequence of strings. Field names can be a single string with each field separated by white space. Any valid identifier can use a field name. Okay. Except with underscore. Rename is true. Example, this is converted to this. I don't understand. Anyway, so we need to provide a type name. Oh, it's a type. It's a type. And then we say in Spanish, this is 11, this is 12, 22. And we should do x, y equals p, p dot x, p dot y, p is point. Alright. Anyway, that's not what we're here for. We're here for a counter. It has a function called, is it elements? No, element. No, that's not. Most common, that's the one, most common. List of n most common elements and their counts. From the most common to if n is omitted, all elements in the counter. Nah, that's not what we want. Total. Update. That's it. Most common. I cannot do most common because it doesn't stop. It doesn't like return. It doesn't say like return all the elements with say 5 occurrences, and no such a function. I mean, it's easy to write. All right, so I think we'll probably do the same thing in the past. So we just do nums, right? Counter equals counter nums, and then we simply return this, right? We're gonna say for I see in enumerate, not enumerate, counter dot items, right? And then we say if C is larger equals 2, right? If C is equal to 2, I return I, and if we run sample, test it, let's say it has to be. I didn't say it has to be sorted. So I can submit this. Yep, just to get it. There are 2 oncoming times for this challenge, and you have 1 ticket left for this month. If you want to use it to make up for this submission. Yes, we want to make up for this because the next one tomorrow I can do it tomorrow. So we select yes, and then we've done this. Perfect. Okay, now coming. Oh no, I don't want to see the solution. Come on, I want to see the description. All right, so this is not gonna. I'm not gonna record this because it's not constant space. Now we're trying to figure out if we can do a constant space. Yes, we can. I think what we need is, of course it can. So we have length is n, and we have value is 1 to n, right? 1 to n. And each number appears once or twice. So we can just swap, right? That's what I have in my mind right now. We just swap. Let's try. So we have 4. 1, 2, 3, 4, 5, 6, 7, 8. We have 8 values. So 1, 2, 3, 4, 5, 6, 7, 8. 4, 3, 2, 7, right? 8, 2, 3, 1. So we basically just swap. So first element is 4. So we go to 4, so 0, O. We don't go to 4, we go to 4 minus 1, because it's 1 to n. So 4 minus 1, so go to 0, 1, 2, 3. So this one goes here. And then this position is 7, so we're going to go to 7. And 7, we have found 3, so we go to 3. 3 we find is here, right? So we find 2, 2 go to 2. And at 2, we find 3 again, so we go to 3. And then we go to 3, and find out 3 is already 3, right? 3 is already 3. Then we say, oops, 3 is the answer. So 3 is the answer. Now, once we remove then what? So to make it ON, each position needs to visit only once, right? So we should go back to the front. And then, wait, how do we know which position have not been visited before? The start, once we take it out, it's going to be, let's just say that like 0, right? 0, 0. Put in the 0. Put actually to -1. Put into -1. So we have these all filled. We need to start from the front again. And then we're going to go through every single one until we find one that we haven't hit. So it'll be 8 we have not hit. So 8, we move to 8. And then holy moly, I think I got it wrong. No, that's right. And then 1, I'm going to move to this, right? 1 move here. And then -1, if we set it to -1, then there's nothing, right? And then keep going. Is that ON? Is that O? So like how many rounds we have to go through? Can we like not jumping around? We'll try it again. It's like jumping around feels 5, 6, 7, right? Jumping around. Jumping around doesn't feel right to me. Let's try it again. 4, 3, 2, 7, 8, 2, 3, 1, right? So if we don't jump around, so first one, we're gonna go to 0, 1, 2, 3, right? So we go to 4. Oh, if we don't jump around, then we cannot save the value. Okay. We go to 4. Seven, we go here, 3, we go here, like we jump around, and it will end up when we encounter a repeat, right? Encounter repeat. So when we encounter repeat, what do? We keep going forward. Huh. I mean, my idea is we just start from every time we hit, right? We always start from the beginning, right? We always start from the beginning and search again, and until there will be a moment when we go through everything. It's either -1, which means they do not exist at a value, or yeah, that's eventually like everything either it's the same or it's -1. So the question is, how many rounds do we need to do this? Okay, so if there's no twice, no duplicates. If there's no duplicate and we fill the entire array, that means every value occurred once. Then we just keep jumping, right, until we cannot, right? Because there's no duplicate, so we will jump, jump, and then we go again. So like 2 times the maximum. Right, so do 2 jumps, or a couple of jumps, right? A couple of jumps put these values in position, and eventually we'll jump back here, which will cause us to find a -1. That's actually fine if it's -1. Now we just say this one will +1. No, the actual value is -1. Right, the actual value is -1. Doesn't matter. So if like we find this +1 is -1, that's a sentinel. And we say, okay, the current round ends, so we go back to the start. And we'll skip, skip, skip it once, and then we do it again. And skip, skip, skip. So would it be possible every time we swap only once? Swap, going back to the front. Swap, going back to the front. Swap, going back to the front. So what? This will be, we'll spot n times. But we have to go through the entire thing. Let me think, is that ON? Yeah, that's actually ON squared. Because we, like every time we start from the front. And that's the problem. Oh, hold on. We can sort it, right? Oh, but sort is not ON, it's ON log n. How can we use jump to avoid it? Huh. If we jump, like right after we jump, so we jump, and then we push this value here. Okay? And now 4 is here. And then we say, let's go forward. 8. And that's not jump, that's just swap, right? We swap, and we come here. And then we go to the front. 7, and we swap. And then 8 again. 3, we swap, right? After swap, 4 good. 1, now we swap. 3. Oh, that's duplicate, so we add that to it. And then just keep looking, right? Keep looking, looking. Okay, that's a 2, so we swap. Right, and then we just -1. -1, we just simply skip 2, Okay, 2, we already have it. So 2 is another value, and then we'll get -1. Go. How do we know when it ends? What if like each time we swap, right? And after swap, we always stay at the front. Right? We swap, stay at the front, we swap. We swap and then stay in the front. Okay. Let's try it again. 1, 2, 3, 4, 5, 6, 7. 4, 3, 2, 7, 8, 2, 3, 1. What I'm saying is every time we swap, we stay at the front. So 4 swap, right? Once we swap, we stay at the front. So 7, we're gonna swap, right? 7 swap, and we'll stay at the front. 3 swap, stay at the front. 2 swap, okay? And then 3 in the swap. Boom, cannot swap. If I cannot swap, I turn myself into -1. And then I move on. Boom, good. Boom, first one is now good, so that's the front. So front we set up to this one, right? There's 8, so we swap. 8 here, 1 here. And then 1, we're gonna swap back. Alright? That's swapping back. Now the only time that we are moving forward is if we encounter a duplicate, right? That's the only time that we will go forward. And every time we go forward, we stop at the first one that has not been done yet. So if we swap it, we don't have to go back because everybody else has already fit. So we swap, right? 1. Basically, we have -1 here. And -1 is good, right? So we swap. -1 is good, so we keep going. And then front comes here. And then this, boom, already. So we go -1. So we keep forward, and then end. So in that way, I'm able to do OM. I'm able to just, every cell is visited once. Everything is visited once. No, everything is visited twice. Every cell is visited twice. Let's try this one. I'm not sure if I do it the same way in the past. But this one takes some time. Yeah, because I do not want to go back to the front every single time. That's gonna just make things very, very slow, right? Very slow. What we want is keep a record of where we are, so we don't have to keep going to the front. All right, so we're gonna do this in place. None of these, right? Okay, so we're gonna have a front. I'm gonna call it F. F is gonna be 0, right? And then we say while F is smaller than lambdams -1. And then we can actually say n equals lambdams to make things easier. All right, so if front, I just say index. I just say I, we just make things easier and easier every single time. So that's I, right? And then we just look at I, and then we keep swapping until I becomes -1. When I -1, we just move forward, and we just say while nums I is not equal to while it's not equal to -1, right? Hold on. So we need to while Two while loops. Nums I is equal to -1, or nums I is equal to I plus 1, right? If these are, then I plus equal 1. So keep going until, and then we say while this is not equal to nums 1, then nums I and nums, so nums I is going to equal to nums I minus 1. Alright? And then nums, we're swapping, so nums I minus 1 will equal to nums I. That's the actual position. Right? That's the actual position. The value minus 1, so we will swap. Well, we cannot really swap, so we have to first check, right? We need to check. So I have a value. I want to swap to a position. So let's make it clear. So the ni, right? Next I, it should be nums I minus 1. This is where I supposed to be, right? And then we say if nums I current is not equal to nums ni. So these are not the same. And then we can do nums I, right? Nums ni equals nums ni and nums I. So that's the swap. Else, that means we have, so the nums I and nums ni, they're the same, then we have the duplicate. Duplicate, we set this to -1, and then a result, rest equals to 0. Right, then we say rest.append nums I, that's the duplicate. And then when we have a duplicate, we set this to -1, right? And then we're going to go back up, and that will be -1, so we're going to move forward. And in this case, if it's this, then we simply swap the two, right? We swap the two, and we go back up, and then the correct is moving to ni, right? The correct into ni. So I think this is right. And then eventually we're going to return this. That's not 0. Come on, that's this. Okay, this is my solution for a ON. Let's run some test case. So we have this, answer 2, 3. Right, second one, that's 1, 1, 2. Okay, so second one is going to be 1, 1, 2. Answer is 1. Third one is 1. And answer is empty, right? So this one can be nums. This is find duplicates nums. I have to go sort it. Let's be sorted. Oh, we have error. List out of range. While this is equal to -1, or this equals to I plus 1. How do we get out of range? Oh, and then this is actually smaller than I, not smaller than I minus 1. That is weird. Index out of range. Zero, 0, 4, 5. Oh, yes, yes. So I shall equal to I plus 1 and mod n. Right? Wait, mod n or mod n minus 1? Mod n, because this is 0 based, right? So wait. Oh, hold on. This one will keep going. So this one will keep going, and then it hits the end, right? And it'll become 0. That will be an infinite loop. That will be an infinite loop. Like, what the hell? Then how do we decide? Yeah, 0, 0, we go to 4, go to 5, and then we go all the way to the end. Ooh. Gets out. Then we do a bunch of stuff. Back up. And then we run. And then we don't find anything. How do we know that it has go through the entire thing? Huh. So we just, when it goes through the entire thing, is we run through the entire range, and then we don't find any issue. Right? That's when we say we are good. We swap, we swap, we swap. Hold on, it shouldn't. So we go, so swap 0. So swap 0, swap 7. 0, 7 going to here. That's 3. No, it shouldn't be. I is not. Right, because initially it's 4 swap. 7. Alright, 7 will swap with 3. 3 will swap with 2. 2 shall swap with this. And then we have issue. Which means initially is should be 0 in. And then this one will go through a bunch. And when it comes out, I shall still be 0. So I is 0 in, 0 out. Oh, 0, 1, 2, 3, 4. Oh, that's true. That's true because all these are done for. So it's correct. It is correct. So I can just say while true. Not really. I just while this, and while I smaller than n, and I plus equal to 1. Yeah, that's correct. No, it's not correct. We're still out of range. How? I already say I is smaller than n. I smaller than n, and everything. Eight. Is it n is 8? Two, three, four, five, six, 7, 8. Huh? 8 coming up. 8 smaller than n should be false. outside I, and this is going to be inside. Let's call it inside I. Outside 0, 0, inside. Outside is 4. 0, 1, 2, 3, 4, inside is 5. And outside is 5. Inside is 6, 7, 8. Alright? Inside 6, 7, 8. Oh, this, I have an or if this and, that's why. Parentheses. What the heck? Oh yeah. Yeah, we shall be able to return here directly. I smaller n. Append first and then set to -1. There you go. There you go. So this is on. Took half an hour. Jeez, it's like quite simple question. I don't know why it takes so long. Yeah, I have faith. I think this is correct. I think this is jeez. I think this is what they're looking for. Try all of them. Yep. All right, let's try this one. This thing is on. Ooh, wrong answer. What? What? We are wrong answer. 2, 1 shall be empty. What do we have? We have 1. Interesting. So I is 0 and is 2. I is smaller than I is 0. If this is, no, it's not. So we come in here. While I is smaller than n, and nums I not equal to, okay. Ni is nums I 2 minus 1 1. If nums I is 2 is not equal to this, not equal, so we swap, right? And after swap, we go back up. And smaller than this, and nums I is not equal to, nums I is not equal to. Oh, we forgot. It has to be this thing. Like, the constant swap will end once we finish this. Oh no. No, that's not true. Wait, what? It's not -1. Now we just keep swapping. And now we are actually sorted, right? And now 1. And then next is a 0. Oh, I see how it goes. So what if I swap and I become the right value? Well, if I become the correct value, I shall just move forward, right? Which means if this is smaller than n, or this is this, or nums 0. Oh, that should be not equal to. Jeez, not equal to, or this is not equal to. No. What the heck? Still not right. How? I is 0, right? And nums I is not equal to -1, that's true. If it's not equal to -1, oh, because this is always true if it's not equal to -1. And we'll say or not equal to. But not equal to -1 and not equal. It shouldn't be and, right? I think it's and. Like if it's not equal to -1, like if it's equal to -1, then boom. And then we say and it's not equal to itself, the correct, if it is. So this, okay, this will pass. All right, so let's change this a little bit as condition. All right, so the while loop, the second while loop. All right, try it. Pending, judging. 416. 416. All right, so 416. Kind of feels slow, right? What do we say? This is we use swap to put one value to its correct position, right? And then after that, we remain at the front, remain at the front, and keep swapping until the front value is either -1, which means we have encountered a duplicate, a duplicate, or the same, or the front value is in the same, in the correct position. When either of these two scenarios happen, we move the front pointer forward until hitting a new wrong position, right? And it works because we don't care about -1. -1 will be fulfilled or it might not be fulfilled, doesn't really matter. All we want to know is the duplicates. So this is ON and time and O1 in space, right? I mean, technically it's O2N, right? It's O2N time. I didn't go too good. I got a 416 and a 35% ranking. All right, time to check my previous answers. All right, I have so many of them. So I have 1, 2, 3, and 4. They feel very much the same to me. I'll also go on to the discussion. All right. Let's take a look at what I said. My, it's so slow. 1 year, 2 months ago. Look at that. 28 test case. Okay, what was I doing this time? I have no idea what I was doing. I just know I don't like it because it feels convoluted. I have this n underscore as a length. set ni equals 0, and I'm jumping. And this is me jumping. Okay. I like how I jump right now. It's clearer to me. What is this? Counter. That was interesting. Using the counter method scored so low back then, but now it scores very high. I feel like something's changed. A bag, a res. Okay, this is not O. This is not O1 space. It's ON in time, but not O1 space. I think I'm just trying things. I think this is a solution. For any nums, if nums ABS this -1 is smaller than 0, rest.append ABS n, else nums this equal to -1. So for n in nums, right? So n is current value, and we do value -1. That's its position, right? That's its position, and that's the exact position. ABS n -1. That's its position, and we check if the position is smaller than 0. Let's say the position not smaller than 0. Which is go here. If it's not smaller than 0, then we set that value to a negative. Right? I set that value to negative value. I mean, I'm not changing anything. I just set it to negative value. Okay? So the next one, if it's larger than 0, that means it's swappable, right? And if we encounter a 1, which it is smaller than 0, that means that one has been swapped for. So I need to append the absolute n right now, right? And so what we're saying is we always check where we are going to swap the value to, right? So we given a value, we're going to swap there, but if somebody has swapped there already, then I must be duplicate. I just go one by one and check. Wow, this is very smart. This is very smart. So still same number of test cases, 28. Yeah, 28 test cases. Do you want to write the good solution again? Yeah, we can write the good solution again. That's fine. So, but this is my attempt, right? This is my attempt. But the good solution is good. The good solution is good. So this is the good solution. This is the good solution from the last time I attempted this problem. The idea is to mark in nums which position can be correctly fulfilled without actually making a swap. We can set the num value to negative to indicate that the that there is a correct value for the position where the current num resides. Duplicate is detected, right? Is detected if current values, right, is correct position. Current value's correct position is negative. This means that position has been occupied already. Right. So for this, rest is going to be equal to this. And for any nums, right? So first thing we need to check, say if nums abs n minus 1, if it's smaller than 0, then rest.append abs n. That means we have found a duplicate. Something has occupied that position before. Else, if it's larger than 0, then we set that value to negative, which makes nums abs n minus 1 times equal minus 1. So we set it to negative. And all the ones we visit, we don't visit them again. On the return rest. Such an elegant solution. Yep, I am going to submit again. So I'm going to go first, just in case. That's good. Judging. Oh, this is fast too. All right, let's see. What do the people say? Yep, that's the very creative. Yeah, this is a very creative method. All right, so if we refresh this, I think should show that we have accomplished this. Hopefully, I spent 70 LeetCoin for this. Where's LeetCode what? Oh, come on. Oh, this is 0 now. Wow. What the hell happened? So like all the internet speed goes to the upload, and then I can't even download stuff. And this is not correct. JavaScript is not loaded. So something is very wrong. I think I need to turn the laptop off. Oh, here we see. Which one is this one? I just want a number.